Welcome to the Real Python Podcast. This is episode 5. Have you wanted to explore using Python with electronics? CircuitPython's a great platform to get started with. This week, I talk with Thea Flowers. Thea's been creating several hardware projects that are based around CircuitPython. She talks about how she taught herself to design and prototype printed circuit boards, and I ask her about how someone would get started with CircuitPython. We also discuss several of her open source projects. She was the conference co-chair for PyCascades, and I asked her about how people could get involved in volunteering for conferences. We also talk about building diversity in the community. This episode was recorded at an earlier date, and so much has changed in the last several weeks. I asked Thea to come back for an update about her projects and about a recent honor bestowed upon her. So let's get started. My name is Christopher Bailey, your host. The Real Python Podcast is a weekly conversation about using Python in the real world, interviews with experts in the community, and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hi, Thea. Welcome to the podcast.
Hi.
So why don't you give us a little bit of your programming background?
Yes, it was a long time ago. I got into programming because of video games, actually. When I was like 12 and 13, I wanted nothing more than to make video games, basically. So I started programming in this tool called Game Maker.
Yeah.
Which is very different now than it was then. But like back then, it was made by one guy. And it had this like drag and drop sort of interface for creating games. But you could also program in this scripting language called Game Maker language, or GML.
Okay.
Yeah, so I ended up learning GML and then eventually like made a couple of little games that I'm never going to show anybody ever.
Sure.
Yeah, and then from there I learned like, C and C++ and a couple of other languages. And that was all in high school, basically. And when I was graduating from high school, I unfortunately didn't get a chance to go to college. So I sort of like weaseled my way into the industry, as I like to say. Ended up, after failing to become a famous musician, I ended up working at a little web design firm in my hometown, writing PHP.
Okay.
Yep. So that was fun. From there, I went to consulting and then eventually landed at Google.
Yeah, we were talking a little bit just before we started. I just did a recording with Brett Slatkin, and you were mentioning a little bit about your indirect experience with him through App Engine.
Yeah, so before I started at Google, I was working at a consultancy, and we did a lot of stuff with Google Cloud stuff at the time. We would migrate companies that were using like old school Lotus Notes or Microsoft products or something like that over to Google Cloud. And inevitably, all these companies have some kind of like custom software that they would have that was built around their existing systems, be it Lotus Notes or whatever. And so I worked on this team who specialized in porting those apps or recreating those apps onto Google Cloud Platform.
Yeah.
So I get to do a lot of App Engine and a lot of Python. Got heavily involved in the App Engine community because of that, and definitely have experienced indirectly a lot of Brett Slatkin's work. So, yeah.
Did you approach Google or did they approach you?
I approached Google. I was working at this consultancy and working a lot and not getting paid very much. And I also wanted a change from Atlanta, which was where I was living at the time. I want to go out west because everyone wants to leave their hometown, right?
Sure.
Yes. I interviewed at a couple of companies and Google was one of the top on the list. And after 10 interviews,
wow,
I convinced them to hire me. So
nice. So what are you working on currently at Google?
Yeah, so I transferred to the Flutter team last year, the Flutter developer relations team. So at the moment, I am doing Flutter stuff. So I'm programming in Dart and creating examples and all kinds of cool stuff for Flutter. For those of you who don't know what Flutter is, it's a cross-platform UI toolkit, which is really, really cool. Lets you design apps and run them on iOS, Android, and we have web coming very soon, if not already launched. I don't know. I haven't been keeping up with that. And we have desktop support in beta, or alpha or something like that. But it's coming. So it's pretty cool.
Yeah, awesome. So your Python background started with App Engine.
Oh, it actually started way before that.
Oh, really? Okay.
So, I mentioned I wanted to make games in high school. That's what I did with my programming, basically. Like any sort of programming I was doing was related to games.
Okay.
So at one point I wrote a 2D game engine, and I wanted a way to have it build every time that I made a commit in Subversion. This is how old that is.
Yeah.
I was still using Subversion. Git didn't exist yet. I built a build bot using Python way back then. And it was great. And I think it even used because Jinja 2 didn't exist yet, right? So I used Cheetah templates. I think that was what it was.
Oh, wow. I'm not familiar with that.
It's old school. So yeah, I used Python back when I was a teenager.
Okay.
I did PHP for a while. And then, when I moved to this consultancy, I was they were all using Java at the time, which Java's a fine language or whatever, but it's not always a fine language for rapid iteration and responding quickly to customer demands when they change their mind. So I convinced them to try Python, and it worked out really well for me, I think.
Yeah. And since then, you've been, along with getting your position at Google, you've been doing a lot of open source projects. And
yeah,
tell me about one of the ones you're working on right now.
Yeah, absolutely. I've kind of taken a step back from a lot of my sort of bigger open source engagements.
Okay.
For my health. Really kind of, turn down the knob on how much I'm involved in a lot of different things that aren't projects that I sort of originated.
Sure.
So I'd say my biggest two open source projects right now are Nox. So that's Nox. And Nox is very similar to Tox, but it uses Python as the configuration instead of any files. It seems to be doing well. I am not the only maintainer, which makes my life a lot easier.
Yeah.
But yeah, it's really great. And I never really expected that to get any adoption outside of my personal projects and the projects I had a say in at Google that use it. But yeah, it's been going really well. And the other open source thing that I'm kind of still sort of heavily involved in is ConductHotline.com.
Okay. Which
lets events sort of create a phone number that attendees can call to reach event coordinators, and it maintains anonymity and all this cool stuff. And it's really useful tool, and I offered that for free to conferences to use.
I went to Pi Colorado, and I believe they were using it there.
Yeah, I think so. I'm trying to remember. Yeah, I think so.
Yeah,
it's really useful tool, and it's so simple to set up, and it makes everyone's lives a little bit easier. And beyond that, I am contributing to CircuitPython a bit, and really love that community. It's one of the best open source communities I've ever been a part of. I absolutely love it.
Yeah, I definitely want to dive into CircuitPython with you. Just to take a step back, though, can we talk a little bit about Nox?
Sure.
If somebody was okay, I want to get more into testing, they might be somewhat familiar with this tool, Tox, or even maybe we start there. What does Tox provide?
Yeah, I actually did a wonderful PyCon talk about this. You could actually go look at my talk from 2019.
Okay, cool. All right, we'll link to that.
Yeah, that goes into a lot more depth here. But the basic description is if you're doing something over and over again, if you're having to create a virtual environment, install PyTest, install your dependencies, and then run PyTest, and you're just doing that over and over again,
yeah,
Tox and Nox can automate that.
Okay.
So instead of running all of those little commands and trying to remember every step, you would just run Tox and it would do that for you. And because it can automate that, you can actually automate those steps in different Pythons. So you can run your test against Python 3.5, 3.6, 3.7, 3.8, and so on, so that you can make sure that your program or library or whatever works on every Python version that you want to support, which is really cool.
Okay. I could see how that would be really vital as somebody creating an open source tool, that you need to make sure that it supports a wider audience, or even the code base at Google or some of the projects you're doing there.
Yeah.
Yeah, cool. And so Nox, you build on top of Tox somewhat.
It's an entirely, what I like to call a different implementation of the same idea, right?
Okay, sure.
It tries to solve the same problem just in a different way. And I think that Tox is great if it works for your use case, but if you're trying to color a little bit outside the lines with Tox, it becomes increasingly more difficult, exponentially. But with Nox, if you start coloring outside the lines of Tox, try Nox, because Nox is going to let you color outside those lines a little bit easier because of the way that it's designed.
Okay.
So it's kind of it's allowing you to break the abstractions a lot more easily, basically.
Yeah, I'm very interested in this idea of not having to go through a checklist of commands every time to test something. So
yeah, me too. I do not like that.
yeah. How'd you get involved with CircuitPython?
Yes. So after I switched over to the Flutter team, I stopped doing Python every day at work.
Okay.
Which was a big change for me, right? Like, I love Python. Like, I've been programming Python for like a decade now. I was like, okay, I don't want to lose my connection to the Python community, basically. Like, I was lucky enough to like make my job involve Python for a while, but now I had like kind of lost that. And I was like, okay, what do I do? How do I get back into being connected to the Python community without having to do it every day at work? And I've been getting involved and interested in electronics for about a year before this. I built a synthesizer using the sound chip from the Sega Genesis, and I programmed that in C and C++. And I know C and C++, but it wasn't a fun experience.
Okay.
And, I thought to myself, I was like, well, there's this thing called CircuitPython. Maybe I should check that out for my synth projects. So I started looking into it, and I was like, oh, this is awesome. Like, the ability to just sort of edit a file and save it and have that be your microcontroller code is awesome. Like, it's so much of a better loop than like opening up the Arduino IDE and compiling, waiting for compilation, waiting for it to flash things, all this stuff. It's great. And also it's Python, and I get to continue writing Python.
Right.
Yeah. So like, that's kind of how I got interested in it. And then from there, I ended up where I am now, which is like designing 2 separate synthesizer projects using CircuitPython. So
yeah, cool. That rapid implementation is something that I think everybody loves, in some ways about Python in general, like the idea that it doesn't have to compile. When I talked to Brett Slacken about it a little bit, he was saying that's one of the things he really liked when he started using Python at Google, is like setting up all these things that manage all the servers. And it was nice to be able to iterate quickly. And I could see that with electronics, moving to something that's even more in the physical world right in front of you and being able to send the code to it and have it run. Something I'm very excited about too, because I dabble in electronics, but I haven't gotten into MicroPython or CircuitPython at all. And I'm just that's why I'm super interested. It's like I built guitar pedals and things like that, and I really want to
awesome
try to learn how to program this stuff. So that's something I was interested in a little bit about was, okay, so MicroPython, and what's the difference between that and CircuitPython?
Yeah. So that, like, this has kind of been talked to death, but like, so
has it? Okay. Sorry.
Yeah, a little bit. It's fine. So like, MicroPython is sort of one of the original projects that tried to bring Python to small devices.
Okay.
It's great. It's a wonderful project, and it has its own goals. CircuitPython is a fork of that. That's a little bit more education friendly, right? Like, the goals of CircuitPython are explicitly different from MicroPython. And the idea is to make CircuitPython very approachable to beginners. And there's a lot of changes that have been made to that end, right? Like, one of the major differences you'll notice if you switch between MicroPython and CircuitPython is that MicroPython doesn't really adhere to standard library conventions. So like, there's not like an OS module that's emulated.
Oh, okay.
And so on and so forth. Whereas like, CircuitPython is explicitly designed to be as compatible with upstream CPython as possible so that you can port code between the two. And it kind of helps a lot because there's a lot of CircuitPython code that can also run on like the Raspberry Pi with CPython, right? So that's kind of the idea, is like, let's make it approachable and let's make it as education friendly as we possibly can. And I think that that's a really good goal.
Yeah. I was reading a little bit about it, and the idea that when you attach this hardware to your computer, that it can just appear like a connected drive.
Yeah, that's awesome.
Okay, cool. If you were going to get one of these boards, do you have a suggestion as to where someone would start? Like, what hardware board would be a good choice?
Yeah, absolutely. I think sort of the ultimate starter is like the Circuit Playground Express, right? It has so much stuff on it. It has like a ring of LEDs. It has a microphone. It has a little speaker. It has, I think they have accelerometers and temperature sensors. Like, there's a bunch of stuff just already on the board for you to play with. So you don't even have to wire anything up to start experimenting with code and like sensors and like the physical world, basically.
Yeah.
So I think that's a really great option. And, I definitely see people's faces light up when they get the LEDs, showing different colors and stuff like that. It's really, really wonderful.
Figuratively and literally. That's cool.
Yeah, exactly. And, the other ones that I would recommend is like any of like the Pi badges. They have little screens on them and like buttons and stuff. So you can, if you're more of a visual person, you can actually, display things on the screen and make them move around and like even make little games on them if you want to. So I think either of those are a great option. The Circuit Playground Express is going to give you a little bit more to play with out of the box, but the Pi badge is going to give you a screen. So,
nice.
Maybe either or both, whatever you want to get into.
Yeah, I'm probably going to get both.
Yeah, and they're not very expensive at all. I think there's a low cost version of the Pi badge. It's like $25 or something. So,
what are some of the things that you, as far as like projects that you are excited about in CircuitPython?
Oh, that's such a big question.
Okay.
There's so many like really interesting projects going on. Not to get into any specific projects, but like I am personally really excited about the Bluetooth stuff that's coming or is sort of present in the CircuitPython 5.
Okay.
Which I think is in release candidate right now. So it should, like, maybe by the time this podcast comes out, we'll have the final release of CircuitPython 5 with the Bluetooth.
Okay.
But like, it's awesome because it lets CircuitPython devices not only communicate with like phones, computers and stuff, but communicate with each other.
Oh, okay. Yeah.
I think there's all kinds of really cool stuff. My friend Nina is adapting a project from Sophie Wong, maybe? Yeah. That is like a jacket that has like LEDs on it and then like 3D printed little gems covering the LEDs, which is really cool, like diffusers. And she's using CircuitPython for that. And having Bluetooth as the ability to like control that from your phone is really powerful. Or, being able to detect other Bluetooth devices and react to those is really cool as well.
Yeah, that sounds very cool.
Yeah.
I saw that Nina's doing a talk at PyCon. I think it's in a similar space here too with CircuitPython. I know she's done a variety of Twitch streams and other stuff, showing some of the projects she's working on.
Yeah, her streams are great. You should definitely check them out if you haven't seen them.
Yeah, I'm going to link to that. I'm thinking about the Bluetooth thing. Would that be possible to send audio across also then?
I think so. I haven't had a chance to play with that yet, so I can't speak authoritatively on that, but
sure.
I can't see why not.
Right.
CircuitPython definitely isn't as fast as C or C++. So if there's any sort of, I guess, limitation, it would just be speed. But we have much faster boards coming soon, so that's a problem that can be solved.
Awesome. What are other things that you'd like to see improved in CircuitPython?
Yeah. Adafruit actually did a really awesome thing at the beginning of the year where they asked people in the CircuitPython community what you love about CircuitPython and what you would like to see improved, which is like such a cool thing to do.
Yeah.
And a lot of us wrote blog posts or sent emails or whatever in response to this. So you can actually go and read my blog where I go into a lot of detail on this. But I think I had like two really big things. And like the first of them was debugging.
Okay.
Right now, like CircuitPython is kind of like print debugging is what you get, right? You brought up Nina. Nina actually has a whole talk about like how awesome debuggers are. And she kind of like really sells the idea of like, you should use an interactive debugger, and because it's really going to save you a lot of trouble in the end. And for me, doing these synthesizer projects, I really do miss having an interactive step debugger on CircuitPython. And like print debugging is really tough sometimes as you start building more and more advanced projects.
I can imagine. Yeah. Okay.
Yeah. So I would love to see like the equivalent of PDB basically on CircuitPython. And, of course, have like integration with that into VS Code or something like that would be amazing. But yeah, I think that's probably my biggest gripe is that. But the other thing that I would like to see is making it easier for me to write native modules. So to write stuff in C and load that into a CircuitPython project.
Okay.
It's possible today, but what you have to do is basically fork CircuitPython and then add code like in the compiled CircuitPython side of things. I try to upstream everything that I can, but sometimes it just doesn't make sense for me to upstream my, audio algorithm to CircuitPython just for one board, right? Like that seems like I'm like putting an unnecessary burden on the CircuitPython maintainers to keep track of my silly audio code, right? So I would like to be able to keep that code separately, but still load it into a CircuitPython project.
Yeah.
that's my other big thing. And, I am happy to roll up my sleeves and help those two things happen. So
you were mentioning that earlier, how CircuitPython would need additional, for lack of a better word, tooling to be able to do more with audio. And so that might end up, I guess in the end, maybe being like a fork where it's like, to do these type of projects, you might need this particular hardware in this version of CircuitPython to have the low-level C stuff to be able to speak with audio and do synthesis and stuff like that.
I mean, I would love for that to not be a fork, right? Like,
okay, it being built in.
Yeah, anything that I think is general enough to be upstreamed, I want to upstream, right? Like, I firmly believe in open source and working together for common goals. So, like, there's a bunch of different CircuitPython hardware and they don't all have the same capabilities, and we already have sort of accommodations for that.
Okay.
But like, I meant more specifically, like, if I'm going to implement some sort of, effects processor and use CircuitPython as the brain, I don't want to have to, upstream my delay effect to CircuitPython, right? Whereas like upstreaming the things that let you play back audio or record audio or process it or whatever, that can live in CircuitPython. It's just the individual like special implementations for one specific product.
Right.
It's something that doesn't feel quite like it should, be upstream.
That's something that's interesting, because that's where you have to figure out where that dividing line is between something that makes sense to be upstream.
Yeah, totally.
You did a couple of posts and things about working toward consensus. Is that part of that in this sense? Like having to, I guess, what is it like trying to work toward consensus with a group of people in open source?
Well, with CircuitPython, it's really easy. Everyone's pretty easygoing and...
oh, good.
So there's no trouble. I think that particular blog post that you're talking about, I wrote when I was working with the Python packaging working group and the Python packaging authority. It is very hard to drive consensus with that group of people. And that's not to say anything bad about those people. They're all great people. It's just there's so many different use cases for Python packaging, right? Whereas like CircuitPython is sort of like, it runs on microcontrollers. It has a very clear use case, right? And very clear goals.
Okay, sure.
Whereas Python packaging has like sort of grown organically over the years to accommodate so many different use cases. And it's kind of really hard to balance all of those concerns, right? And, sort of everyone has strong opinions, but their strong opinions come from their experience and their specific use cases. And they don't always match up with other people's use cases. And when you're doing the job that I was doing, which was maintaining the documentation, packaging.python.org, it is so very difficult to figure out what to write and what to recommend, because you have to caveat a lot of things and you have to drive some level of consensus among this group of people who all have very different use cases and very different ideas about what should be front and center. Because everyone wants their use case to be front and center, right? But like, that's not how we should do things. And yeah, so that's like, that sort of thing is very hard to do. And I think in terms of my tips for driving consensus in that sort of situation is to like, there's a lot of things you can do, like use data, document everything that you can. Like, everyone has these different use cases and they're not always stated. Get an understanding, talk to them, be like, hey, where are you coming from? What sort of things do you actually do with this thing? And write it down. And then once you have a grasp of where everyone's sort of coming from, then you can be like, okay, here's some common things that we can all agree on, and then go from there. And the other thing is like, for packaging.python.org, I was like, what is actually the most common use case for Python developers, right? Is it packaging projects? It's not. A very small percentage of Python developers actually create packages and upload them to the Python package index. It's installing packages. And what are most people installing packages with? Are they installing it with their operating system? Are they installing it with Conda? Are they installing it with pip? I drilled into those and said, okay, most people are installing packages with pip. So let's put that front and center. And having that data and like sort of having enough sort of data and credibility and documentation to back up what you're trying to do when you're driving consensus is really good. And the other thing is there's this psychological trick that's actually a good psychological trick where you get the people involved, right? People feel better about decisions if they have a part, if they feel like they have a say in it, right? So when you say, hey, I want to put pip front and center. What things should I show? Is like this toddler trick of, asking a toddler, do you want to eat French fries or do you want to eat chicken nuggets, instead of asking, do you want to eat dinner, right? Like you give them two choices of dinner and not the choice of whether or not to have dinner. So it's not a choice of, do I put this front and center? It's, I'm going to put this front and center. What specific things should I talk about? And building collaboration helps build consensus, because everyone feels better about something if they have some level of ownership and involvement in it. So,
yeah, that totally makes sense. That's even a problem with my wife as far as dinner. Have to have choices.
Yeah, I am that woman. Like, oh, I don't know, the problem of choice.
Yeah, exactly. You said you were working on 2 different hardware projects inside of CircuitPython right now.
Yep.
Can you tell me about those?
Absolutely. So do you want to hear about the ridiculous one first, or do you want to hear about the useful one first?
I think I've seen in your Twitter stream recently the ridiculous one. So maybe we start with that.
Yeah, this is the smaller of the 2 projects. I am working on a synthesizer module. And for those of you who don't know what modular synthesis is, they're like synthesizers, but instead of one, big keyboard that has a bunch of knobs on it, you have a little enclosure and you put individual modules in it, and then you patch them together using little patch cables. And that's how you make your synthesizer make sounds. I'm building a module that I call the Big Honking Button. And it is a module that has a Sanwa arcade button, like you would see on like the Street Fighter arcade cabinets.
Okay.
And when you press that button, it honks. It makes a goose honk. It's completely useless, completely ridiculous, and I love it. It's great. But I'm lying a little bit, because it's not completely useless, because it's actually really cool, because it's a sampler. Right? I mean, like, you press the button, it plays a sample, and it's going to be running CircuitPython. So you can plug it into your computer via USB, and then you can replace the sample with whatever you want. So if you actually want to use it for real samples, like, a snare drum or a bass drum or something like that, you can just put that file on the Big Honking Button, and it becomes a Big Honking Button that does something other than honk. And I think that's pretty cool.
Yeah, no, I like that idea. It's like, this is a starting place, and this is what could exist on it, but you could definitely go in and, by looking at the code, figure out what you could replace inside of it and kind of make it your own.
Definitely.
It's kind of like the starter of a soundboard of sorts.
Yeah, exactly. It's like a soundboard, but it's just one button. I love it. It's great. It also has pitch control, so you can make it higher pitched and lower pitched, and it's really funny to do that with the goose sound, because goose honk is like honk,
right?
And like when you lower the pitch, it's like this demonic goose is like honk. It's
right.
So great. It's so great.
Is it somewhat inspired by the game, the Untitled Goose Game?
Definitely.
Yeah,
definitely.
That's great.
I think we were all inspired by Untitled Goose Game.
Yeah, I loved it. I recently did the Xbox Game Pass thing to try out a bunch of different games. I was so excited that it was on there. I'm like, okay, this is great. I'm actually kind of excited about the developers and their company Panic are coming out with a little portable game system. I'm very excited about what that's going to be like too.
Yeah.
Again, kind of physical hardware.
Yeah, I love hardware. It's great.
Yeah. So where are you in the progress of creating that?
Yeah, I'm actually making pretty good progress on that. It's a small board, and it's not super complicated. And actually, I made this for a reason. So I'm not just making a honking button just to have something that that makes noise. I wanted an excuse to like implement specific input and output circuits, basically.
Okay.
I hadn't yet designed a circuit that did audio output from CircuitPython, so I wanted to do that. And I hadn't yet designed a circuit that took pitch control voltage into CircuitPython. So I wanted to kind of do those two things.
All right.
And this was a simple way of doing that. Where I'm sort of at with the project is I've designed the schematic and I have designed the circuit board. I have prototyped it on a breadboard, and I've started doing mechanical design to make sure that like the button and the circuit board and the panel all fit together so that I can start actually physically making these things now. So my sort of next steps are to get the circuit board and build one so that I have so I can test the actual hardware, and then finish designing the panel. And in terms of designing the panel, that means just putting some art on it and, putting some text on it that says, this jack is the audio out and this jack is, the pitch control in, and so on and so forth, right?
Okay.
It's actually pretty close to like kind of being done, I guess. There's a long iteration time when it comes to hardware that is very different from software. So when I say it's close to done, that doesn't mean in terms of time. I mean, it's close to done in terms of steps, right? Like,
okay. As you walk down the checklist.
Right, exactly.
You were talking about making circuit boards, and that completely fascinates me because I've dabbled with breadboards and even the other where you're just sort of, they're perforated and you're sort of assembling things through it.
Oh yeah, protoboards.
A protoboard. Yeah. Okay, good.
Yeah.
But the idea of stepping up to like actually having someone create even a simple board, how are you going through that? Like what is the software and tools that you're using to make a board?
Yeah. I started doing this like literally, I think a year ago, maybe a little bit more than a year ago, because of my synthesizer project that used the Sega sound chip, right?
That's the Genesynth?
Yeah, the Genesynth.
If I can pronounce it right.
Yeah. So I actually did that on protoboards, like you said, and it was just too noisy.
Okay.
And so I wanted to reduce noise, and PCBs were the way to go. So PCBs, printed circuit boards. And I covered this a bit in my talk that I gave at Hackaday SuperCon.
Okay.
But yeah, so I was like, I thought that was impossible, right? I was like, first of all, I don't have the software to do that or the knowledge to use the software. And even if I did design a circuit board, how would I get it manufactured? Like, how much money is that going to cost? Like, this is a hobby, not, a full-time job. It turns out I was wrong about everything.
Yeah.
And I love that I was wrong about everything. There is an excellent piece of free software called KiCad. So that's KICAD.
Okay.
And I followed a set of tutorials from DigiKey on YouTube on how to use KiCad. And it was actually pretty straightforward. There's definitely some rough edges on KiCad. Like, you can't just open it up and learn it. But if you follow this little 10-part YouTube series, I think I watched the whole series while I was traveling for work for like 2 days. I did that and I designed my first circuit board, and I was like, oh, this is awesome. Like, this is hard, but like way easier than I thought it would be. And then I found out there's actually like PCB prototyping services where you can order like 5 copies of your PCB for $5, basically. I mean, you have to pay for shipping, but they will manufacture your printed circuit board for $5.
That's amazing.
Yeah, that's amazing. Like, right? And then, I live on the West Coast, and so shipping from China is actually pretty fast. And I think like the first time I ordered circuit boards, they came like a week later, and I was just like,
wow,
whoa, that's silly. Like, I expected like,
yeah.
A 2-month turnaround or something, right? And thousands of dollars, but this was $5 in a week.
Yeah, that's cool.
Yeah, kind of blew my mind.
I think to myself, like, I was in a band in the 90s, and we were like at the cutting edge of, okay, hey, we're, instead of passing around cassette tapes, we're going to make a CD. And and the whole process of making a CD is so much more at that time dramatically expensive and cost prohibitive, and you have to make 1,000 of them, and all these things that kind of get in the way of it. And so that was like my immediate thoughts as I said, okay, I'm going to try to make a circuit board, and what if I make something wrong? And I can, as far as like finding out you were wrong about things in the best possible ways, that's very cool.
Yeah, and I feel that way about like revisions I have to do on hardware too. Like, for my other CircuitPython project, I'm on like board revision 5 now.
Okay.
That's the board I'm actually going to ship. So yeah, it took me, and I started at V0. So, it's taken me several attempts to get this right, but every time I was wrong in the best way, right? Like, I was wrong because like I'm going to learn something.
Yeah.
And that's the whole point of me doing these hardware projects so far, is not to make money or be famous or anything like that. It's just to learn. And, as long as I'm learning, I'm happy. And that's kind of how I'm trying to approach these hardware projects. So, 6 revisions of a board in, I'm happy to continue to be learning.
Right.
It's taken time and it's taken a little bit of money, but, it's very interesting.
Yeah, that's awesome. So what's the other project?
Yeah, so the other project's called Sol, S-O-L, and it is a useful project. It is a MIDI to control voltage module. So in the world of, modular synthesizers, the way that individual modules communicate with each other is through what's called control voltage. And that's like generally like somewhere between the range of -10 to +10 volts, basically.
Okay.
And these modules use this control voltage to communicate with each other, all kinds of things, right? They can use it to communicate like turn this knob to this value, right? So like, turn up the filter, turn down the filter, turn up the frequency, turn down the frequency, all this interesting stuff. And they can also use it to send pitch data, right? So it uses like modular synthesizers use control voltage to tell what pitch that an oscillator should play at. So if you press middle C on a keyboard, that's got to map to some voltage basically. And I think it's 4 volts, right? And if you play the C above that, that's actually 5 volts. So it's 1 volt per octave.
Okay.
Basically. And so if you play, a G, it's somewhere in between. So the idea behind Soul is to bridge the gap between the digital realm of computers and MIDI and USB and the analog realm of modular synthesizers. So what Soul does is allows you to plug in a USB cable to your computer, and then you can send MIDI data to Soul, and then Soul will translate that into control voltage that you can use to control various aspects of your modular synthesizer. So this is really awesome for music production because you can record what you're playing as MIDI notes. You can modify them and change them, and then you can play those MIDI notes through Soul, and then Soul will use that to control your modular synthesizer. It's really, really powerful stuff. And there's already modules out there like this that exist, but what makes Soul really, really cool is that it's running CircuitPython. So when you plug it into your computer, you don't just get a MIDI device that you can just send notes to and they go off into the ether, and you don't know how they get translated into control voltage. You actually see a thumb drive as well, and you can open it up and you can view code.py, and you can see exactly how Soul is translating your MIDI data into control voltage, and you can change it.
Right.
And I'm including all kinds of cool example programs of how you can do various things with Soul through that interface, which is really, really cool.
Yeah, I could think of like if you've ever wanted a arpeggiator, or you want to have all these different things happen that are sort of MIDI specific things that might have been hard to send to control voltage. This is really giving that programmability, and hopefully if you're a Python person, giving you a tool that lets you kind of explore those things.
Yeah, exactly. John Park did a really cool video where he made a quantizer.
Okay.
What that does is basically it snaps the notes into a specific scale. So like he's like, okay, I'm just going to quantize this to the C major scale or something like that. So no matter what note he played on his MIDI controller, his computer or whatever through Soul, it would snap it to the nearest note that's in the C major scale. So you can never play out of key. So you can do things like that. You could process the data and make sure that it doesn't go outside of that range or things like that. So there's all kinds of really neat stuff that you can do.
Yeah, that's cool. If someone was interested in this project, and I know it's not completely done yet, but where would you like stay up to date on it and eventually be able to purchase something like that?
Yeah, there is a mailing list that you can join. So you can go to my Twitter and you can click my pinned tweet and you can find the mailing list, basically.
Okay.
We can also include a link in the description here. There's an information page at winter.dev/soul, and that's WNTR.dev/SOL. And you can read all about the project there, and you can sign up for the mailing list to be notified when it's ready. In the meantime, it's completely open source. The hardware design, the software, the firmware, everything's already open source and on my GitHub. So, if you're super brave, you are more than welcome to go ahead and check it out. That's totally allowed.
Cool. If we were going to dive a little deeper into using CircuitPython and someone was setting up, say, the Circuit Playground Express, what do you use to edit the code there?
So I use VS Code, but you can use basically any text editor, right? Like,
okay,
obviously you have to be like a little bit aware of like Python is white space sensitive. So, maybe Notepad isn't the best option.
Okay.
But yeah, any editor is fine. I think for beginners, the best option is Mu, which is MU. It's an editor specifically designed for CircuitPython and MicroPython. And it's great because it automatically detects boards. It can automatically connect to their serial ports. So you can actually see the output from the device, like if you do print.
Oh, nice.
Yeah, and you can also access the REPL from there. So you can, hit Control-C in the terminal in the serial window, and you can actually access the CircuitPython REPL from within Mu, which is really, really cool. So that's a great option for people who are new to this because it's kind of all in one. You don't have to leave the program to do other things.
Awesome. So I have some questions that I like to ask, sort of weekly recurring things, and I'm working on some new ones. One of them I was thinking about is there's a podcast called Make Me Smart, but I want to kind of take the question they use, modify it a little bit. What's something you thought you understood in Python, but it turned out you were wrong about it?
Oh man, that's a really good question. Gosh, I don't know. Probably threading.
Okay.
In my last role at Google, I had a very interesting set of circumstances that led me to writing some really heavily multi-threaded code. And it, like before that, I was like, I know how to use threads in Python. It's fine, whatever. And I think my hubris was my downfall because it took me a couple of months to really wrap my head around this and get this threading code to where I needed it to be. And I think it still has bugs. And, it's one of those things where it's like on the surface, it seems very simple. And then as soon as you actually try to do anything beyond the very simplest stuff, it starts to hurt your brain. So I think the threading is probably my answer for that. At least the best one that I can think of at the moment.
What are resources you've used to learn more about threading?
Oh God. Pain and suffering.
Okay. Just banging your head against it with code.
Yeah. I don't know. I think there actually is a severe lack of resources when it comes to understanding threading in Python, mostly because every time that you see any resource about threading in Python, everyone's like, don't do it. And okay, fine. But also sometimes threads are the answer. And when they are, we need to know how to actually use them effectively. And so, all of these people who kind of buy into this cargo code of threads are bad aren't actually helping anybody. They're just, preventing people from actually creating and finding resources that are useful. So.
Okay. And the other question is, what else are you excited about in the world of Python? And it could be an event package or, coding tool or some kind of hardware.
Yeah, I'm actually really excited about PyCon US in April. I'm speaking, so that adds to nervousness and excitement.
Yeah.
But also, just looking at the list of speakers and the list of talks, it's going to be really, really good. And I look forward to PyCon every year, and I am super, super excited about it this year. And there's also some really cool stuff that's going to be in the PyLadies auction that I've heard about. So
okay,
I'm very stoked for that. Really, really excited about it.
So what is your talk about?
So my talk is actually about Soul. So I'm going to be talking about controlling the world of modular synthesizers using Python.
You're going to have to haul a lot of equipment with you.
I'm actually probably not going to bring anything with me.
Okay. You could just have ways of demonstrating it through video and such.
Yeah, just pictures and video. I might, though, because I do actually have a really small modular synthesizer that I brought with me to Atlanta when I visited in January. So I stayed in Atlanta for a month in January and just kind of hung out with family and stuff. And so I brought this little tiny modular synthesizer that has 5 modules in it. And I might bring that just so if people want to play with it afterwards or something.
Okay.
Give them a chance to get some hands-on time with it. But I don't know. Haven't decided yet.
Is it in the recording world, they have this thing called a lunchbox. It's like a power supply, and then they'll have a variety of modules in it.
Yeah.
Those are kind of leaning toward a preamp or compressor or something like that, some kind of audio specific thing.
Yeah, it's kind of like that.
Okay, cool. It's not like I'm trying to remember the guy from Erasure, Vince.
No, it's not like that. not by any means. I don't have that much money.
Right. No. Yeah, or the space probably.
Oh, I definitely don't have the space.
Cool. And then the other question I had was, if you listen to music when you code, what type of music do you listen to?
Oh, that's a great question. Wow. I listen to all kinds of different stuff, but I think mostly I tend to listen to instrumental music or music with very little words or words that aren't in English. it helps my brain a little bit.
Right.
So I end up listening to a lot of video game soundtracks, actually.
Oh, okay.
Yeah. Some of my favorites are Celeste by Lena Raine. That's just such a great soundtrack. Also love the Nier Automata soundtrack. It's really good. It does have singing in it, but like the words aren't in English. And I don't think they're in any language, actually. I think it's a made up language for the game. And it's really, really wonderful because it's very like atmospheric and chill. But at the same time, like some of the tracks are really energizing. But yeah, I could talk a lot about music that I listen to in while working, but those are a couple of my favorites.
Cool. Yeah, we'll link to some of that stuff.
Awesome.
I know you worked with PyCascades over the last couple of years. What's your experience working with and being an organizer for PyCascades?
Yeah, it's honestly been really great. In 2019, I served as the co-chair for PyCascades in Seattle. This year, I sort of just kind of helped with whatever. It was no longer my job to be the co-chair, so they got to kind of pick and choose what sort of things that I helped with, which was really good. But yeah, PyCascades is such a wonderful group of people. It's a great set of organizers, but I mean, really, it's the community, right? Like we pulled our organizers from the community, and the Python communities that we have in Vancouver, Seattle, and Portland are just absolutely incredible. And I think this year was really, really good, and speakers and everything were just wonderful. I think it's been good for me because I went through some stuff in my life that made it a little bit harder for me to be on stage and talk in front of audiences and stuff like that for a while. And so I still wanted to be involved in the community. And I think helping organize PyCascades was a really good way for me to like use that energy and that desire to be involved in the community without having to be quite as visible, right? Like,
right.
I think that helped a lot for me. And it meant a lot for me. And, this year kind of like, just running around, taking pictures and helping out with whatever was really fun as well. If you've never volunteered at an event like PyCon or like PyCascades or anything like that, like I strongly encourage people to volunteer. You'll get an easy job if you want an easy job. And it's just great to like be involved, like these events, these like little regional PyCons aren't like professionally run, right? Like we're all volunteers. None of us get paid to do this.
Right.
Like I think this community survives and thrives when we all sort of help out. I strongly encourage people to get involved. Like you don't have to become a co-chair and take on months of work to be involved in the event. You can volunteer, you can do all kinds of cool stuff. I think these little regional events, like, 300 to 500 attendees are really, really special and really important to our community.
Yeah, I was going to ask you like how you would get involved with it, but you hit all those notes. So that's great.
It's mostly a cry for help. It's like, please help us. We need volunteers.
Yeah, I was just looking at PyCon and noticing they put out that call now for volunteers, and it's everything from like helping people getting their stuff set up, on stage to whatever. So it's not necessarily all going to be spotlight. And if you don't have the personality where you want to be right in front of everybody's face, I'm sure they can find a position for you.
Yeah, exactly.
I wanted to ask you about, for this podcast in general, like I'm new to this, and I'm somewhat new to the Python community, and that's partly why I joined Real Python. But I want to meet more people in the community and create relationships in order to get more guests, and so forth. And you had a post the other day on Twitter about how you're looking for more women to be involved in these kind of things like mailing lists and podcasts and so forth. And I immediately reached out to you because I was super interested in what you were doing in CircuitPython and so forth. But I want to be aware of diversity in what I'm creating here also. And it's something that Dan and I talked about initially. Also, we're looking, okay, who are different people that we could reach out to. And I know you did like this very simple survey where you're like, okay, tell me people, like literally, but you have followers and you have people already kind of connected there. And eventually I'm sure that will be something through the podcast I'll build up on. But do you have like advice for me for like, reaching out to people? And, like I'd like to talk to Nina. I'm sure it's something I could just reach out and ask her. And partly again, because I'm super interested in this topic, Yeah. But do you have other advice for me on developing a more diverse podcast, if you will?
Yeah. I think one of the things that I really noticed in my, sorry, this happened like literally yesterday. I tweeted like, if you know someone who's awesome, who's not a man, that does Python stuff, like mention them below. And like, what was amazing to me, even as someone who's been a part of the community for a decade, is like, there were more names on that list that I did not know than names that I did know. And like,
okay,
even someone, that seems connected like me still doesn't know of everyone. And I think, the Python community tends to sometimes be a little insular in terms of like who it highlights and who gets the spotlight. And, so I think my advice is like, seek out voices that aren't already amplified, right? Like, I mean, definitely interview Nina. She's great. Reach out to her. She'll love this. But also like, seek out people who maybe have never done a podcast before. Seek out people who have just done their first talk. Like PyCascades actually prefers to have speakers who are first timers. And the way that we sort of encouraged that was we reached out to local meetups and boot camps and stuff like that and said, hey, if you are at all interested in doing a talk, we will come and help you write your proposal. And we will give you speaker mentors to help you finish up your talk. A lot of times we have to be a little bit more involved in sort of getting people to the point where we want them to be, right? Like, and for podcasts, like, you reach out to someone and you're like, hey, would you be interested in an interview? A lot of people who've never done this before are going to say no because they're scared and shy, right?
Right.
And, I think if you have ways of giving people more support to do this, helps a lot and will help reach voices that aren't necessarily already amplified. So reaching out and saying something like, hey, we're interested in interviewing you for this podcast. If you're interested, let us know. We also offer, mentorship or practice runs or whatever.
Right.
Anything that help you feel more comfortable doing it. And reaching out to specific communities like, PyLadies is the easy one that everyone points to, but there's other diverse and interesting Python communities out there to reach out to and get people that are new and are different voices. And I think that's really, really important.
Yeah, I was thinking about that in general, like the idea of like, okay, if you're nervous about this, there's a particular person at Real Python and I'd asked her about it a little bit and she was very nervous. I said, well, okay, if I give you a set of questions in advance, and then also I was thinking about before I release a podcast, I really want the person to be able to listen to it.
Definitely.
And let them have the choice to say, okay, actually, could you remove that? Or, I would like to come back and talk about this again or something as far as potential ways to ease or allay their fears. And I think in a lot of cases, they'll probably be like, it's all fine. Like it's just, they wanted the ability to be able to say no, which it makes sense,
Yeah.
I appreciate that.
When we amplify diverse voices, it makes it easier for people who come from different backgrounds to see themselves in our community, right? Like, it's hard for a girl to imagine herself being an astronaut if there's no women astronauts, right? Like, I wouldn't say it's hard, but like it's harder, right? Whereas like if you see women doing, and like, non-binary people and Black people and, other people of color, like doing those things, it's easier to imagine yourself doing that community. Like, it's like, people have this idea that tech is like all CS graduates, right?
Right.
That's why I'm very open and public about like my education background, is because, if you see someone who doesn't have a CS background in tech and they're successful, then you can see yourself if that's you, right?
Right.
As we do that and as we amplify these voices, it becomes easier for us to create a more diverse community and have more diverse voices in here. So, I think we should really celebrate that.
Awesome. I want to thank you so much for coming on the podcast and talking to me.
Of course. Thanks for having me. This was really fun.
So that's where the original recording ended. But after a very eventful month, I decided to have Thea come back on and talk a little bit about some of the things that have happened, the changes for PyCon this year, moving from being in person to being online only, get an update on how our projects are going, and a very cool additional announcement. And she also helps to answer the question that we had last week. So here's that conversation. Hey, Thea, welcome back.
Hi.
Yeah, I just wanted to bring you back to talk about some of the things that have happened in the last, month or so since we talked.
Yeah.
And the first off is some really cool stuff. You were making some real progress with your Winterbloom projects. So do you want to talk about those?
Yeah, definitely. I'm really excited because I think by the time this podcast episode comes out, my online store will be open and people will be able to pre-order the CircuitPython powered Eurorack modules that I've made, which is really great. Yeah, it's so cool.
That's awesome.
Yeah, right? The hardware has been finished for a couple weeks now. And I've mostly been waiting for finishing up some stuff around like the business side of things, like my branding and making sure like that all the suppliers that I need for all the components are still working and stuff like that and ready to go. And yeah, so it's so exciting. Like I get to open the store in like a week or two, which is super cool.
Nice. I saw maybe it's an initial pre-order for the button one, but the other one's going to be ready too.
Yep, they're both going to be ready, which is so cool.
All right, fantastic. And then some other kind of really cool news is that you're announced as one of the Python 2020 Q1 Fellow Members. And I'd like to learn a little bit about that.
Yeah, I was so unexpected and really quite an honor to be a PSF Fellow. Yeah, I didn't even know I was nominated, of course, and just like out of nowhere, I checked my work email and I had an email from Ava that was like, "Congrats, you're a fellow." And I'm like, "What?"
Awesome.
Yeah, I'm quite honored. It's pretty amazing.
So it's mainly an honor of what you've been contributing to the PSF in general?
Yeah, it's kind of a way of acknowledging people who go above and beyond for the Python community. There's a long list of fellows for good reason, right? There's been a lot of people who have been instrumental in making Python what it is today.
Sure.
Yeah, it's basically just a way for the PSF to acknowledge people who are outstanding in the community, and I'm in very good company in that list.
Yeah.
So yeah, I'm really honored.
That's cool. So I wanted to talk a little bit about PyCon 2020. Since we spoke, it's been canceled and they're sort of shifting some of the talks to be online. I wanted to talk to you a little bit about what your plans were as far as your talk and if you were planning on doing it or not.
Yeah, I'm actually going to hold off on my talk for now. I gave a lot of thought into giving it online, and I think I'm just going to hold on to it and maybe give it at a regional conference next year when things have hopefully cooled down, and maybe do something else for PyCon next year. And, there's a lot of personal reasons for that, but I'm so sad to see that PyCon got canceled, as most people are.
Yeah.
I don't think anyone's like thrilled that PyCon got canceled, but yeah. And I'm also just like, now's the call to action to say like, the PSF depends so much on PyCon for its income, basically, and to allow it to do all the things that it does, which is wonderful things like give grants to all kinds of places to do good things and make Python better and make the Python community better and do things like education and put on events like PyCascades. It's so important. And, definitely if you were planning on coming to PyCon, try to donate your ticket if you can. And if you are able to donate to the PSF, or encourage your company to donate to the PSF.
Yeah, that's a good time for that.
It's such a good time for that. Yeah. It's so sad. Like it's sad for so many reasons. And I'm glad the PSF is in a state where they can weather this storm at least once.
Right.
I'm really looking forward to next year, and hopefully things will be better.
Yeah, I've donated part of my ticket for that. It's such a important source of funds for them every year, right?
Yeah, and it's so important for the community too. And I would hate for something like PyCon to not happen because of that, right? Like there's no reason that, like, it makes all the sense in the world that PyCon would not happen because of some global pandemic. It doesn't make any sense at all that PyCon wouldn't happen because of financial reasons, right? Like,
sure,
there are very rich companies that use Python, and we need to make sure that like that continues to happen.
Yeah, definitely. So, I had this new listener question. I played it on the last episode with Martin, and it was from the Teaching Python podcast. If you were going to be learning Python, starting over from scratch today, what would you do differently? How would you approach learning differently?
Wow, that is that's a deep question, right?
Yeah, totally. Like Martin and I are kind of fairly new, like only a couple of years in, and I know people that have been learning Python longer, and I wanted to get somebody, a little more veteran than the two of us to say, okay, well, actually a lot has changed, and maybe the number of years that they might approach it differently.
Yeah, the thing is, like, I don't even remember when I learned Python the first time. Like, so like, it's hard to say what I would do differently. I can tell you what I would do if I were learning Python today, which is probably take advantage of a lot of these like actual courses for learning Python, right? I mean, like, I don't remember how I learned Python, but I can guess, right? Which was basically downloading Python and reading documentation and hoping for the best, right? Just copying and pasting code and just trying to guess at how things worked and then, later fixing my broken assumptions. But in this day and age, like, there are wonderful online courses and video courses and things that just give you a much more guided and like thorough introduction to what Python is and how to use it and how it works and all this stuff. And that's absolutely, I think, the way to go, right? If I were going to learn it today, I would not do the absolutely silly method of just go read the documentation and hope for the best that I did.
Right. Hope it sinks in.
Not that the documentation is bad. It's just it suits a different purpose, right? So, no, I can totally see that. There are some people that can think at that programming sort of level. I had a question recently in comments on Real Python site, and the person, I don't know why they picked me out specifically, but I guess they might have liked my other courses or me talking or something. Some real technical question about how Python passes information by references and this whole like super tech. I could tell this person is just a person who's from another language, like they've been working in the world of, C or some other kinds of languages, and now are suddenly have the opportunity to pick up Python. And they're like, talk to me like a programmer. So I sent them straight to the documentation. I sent them to the Python site, highlighted these paragraphs. I'm like, this is the kind of stuff that's going to make sense to you because that's the terminology you've been using, right? So exactly. Yeah, it's like trying to map it to your mental model of how you think the world should work, right?
Right. And everybody learns so differently. People talk about that. And I know it's sometimes considered a myth, the different learning models. But I think, like you said, with video, or even for me, like reading something, watching a video, trying out a tutorial, and then using all these different senses really helped me, even just I was downloading all the podcasts I could about Python at the time just to bring in these other choices. I'm a very audio person though, but so.
No, I get it.
Cool. Hey, I want to thank you so much for coming back on to do this little bit of follow-up on the state of current affairs here.
Absolutely. It's amazing how much things change in like a month. So
yeah, exactly.
I'm happy to come back.
Well, thanks again, and I'll talk to you soon.
Yeah, thanks.
I want to thank Thea Flowers for being my guest this week, and I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and I look forward to talking to you soon.